Hi guys, in this video I'm going to show you how to estimate the PDF, CDF, count and probability of the data. Here is the code. I make a small code to find the count, PDF, probability and CDF, and here is the built-in function of MATLAB. Actually with my code you actually can get the PDF and CDF and count of the data. So it's very simple. You just, for example, in this case I'm just randomly generating some numbers using normal random distribution with a data points of 2 raised power 5 with a mean value of 106 and standard deviation of 15. And now I sort these values, and now actually I estimate the length of the data points. So these two lines actually are giving me number of bins. Either way you can define your number of bins. So if you define your number of bins, then the width of the bin is automatically sorted out by using maximum minus minimum divided by the bin width. Or secondly, you can comment this and you can uncomment this and uh, specify the bin width. So when you define the bin width, then comes up the limits of the bin, and the limits of the bins are minimum, the difference of bin width, and the maximum. So here the code is complete. If you want to have a specific limits, you can comment this and you can uncomment this, and you define your bin limits. And this is just to defining the count, PDF, CDF and the probability to cut the computational cost. And here's the code. So here if I want to calculate, for example, count, I say sum all the values of the sorting, sum of all the values which are less than my bin limit, and then if it's greater than 1, and then minus all these values which are I have previously calculated. Similarly for PDF, you also sum all those values of my sort for each loop, and the loop actually runs the number of times the bin limits, and then divided by the total number of simulations, or you can say here the number of data points actually, and multiply by the bin width. So this is how PDF is calculated, because as you know, in PDF the area under the curve should be equal to 1, while in probability each at every point the sum should be equal to 1, and also in CDF it goes to 1. So in PDF you have to divide by the width of the bin. That's why I divide by dx, and then probability you just divide by the total number of data points, and then you subtract the previous data points probability that you have estimated, and CDF is just the accumulation of the probability. So here, for example, this probability at uh, point I plus the previous CDF. So when you run this, you you will get these two values. Here actually I'm estimating. So here is the figure 1. I'm subplotting count, PDF, probability and CDF by using my own code, and then I actually use the built-in function that MATLAB has, that is histogram. So in histogram I specify the number of bins that I want. If you specify the number of bins that you want, then it will correspondingly automatically calculate the histogram of for the count, PDF, CDF and probability. And you can actually see this here, that the data points that the number of bins we specify 51 is the same as we define for our bin size. And then if you saw the figure, they are approximately the same, but in my case you actually have the values for CDF, and you have the values of count, how many each values are count, how many limits for each value has, and then probability also, and here you have bin limits that you are estimating. I hope this will help you out, and then of course you can copy this code now maybe, and also yeah, and that's just figuring. Yeah, thanks.